Hello everyone. In this video, I'll do a quick review and test a new Peltier element, model TEM1-12706 SR. It differs from the standard one. I've taken a second one for comparison. The standard one has ceramic plates on the top and bottom, while this new model has a metal plate. The specifications state it's aluminum, but its color is bronze-like. Maybe it's some kind of alloy, not specified, or perhaps it's just painted that color. But the plates are cold, so it's metal. However, it's much more expensive, of course. If a standard Peltier element, the 12706, costs around $2, then this model I ordered is a very rare item, costing more than $10. It's either 12 or 15 there. I'll leave a link in the description where the price will be listed. I ordered it a long time ago. I don't remember exactly. Well, around $15, so it's an order of magnitude more expensive. And now we'll test and compare them to see if it makes sense to buy this Peltier and how much more efficient it will be than the other one. We'll connect two in parallel and measure the temperature. Also, if you're interested in such videos, please write in the comments and I'll order other models. A lot of different types have already appeared, and while there are plenty of reviews for standard ones, there are few for these metal ones. There are also two-stage Peltier elements already assembled. They are thicker, with two cooling stages, and they have a large temperature difference. So, if there are many comments and many likes, I'll be able to order different models and test them. If this is a successful model, I'll install it in a car refrigerator, and we'll see what temperature it cools down to. Well, to test all this, I'll connect them to this power supply unit for 12 volts. For continuous operation, it's suitable for one module, meaning one module per power supply. But for a short-term test, I'll connect 2 to 1 power supply, and I think it will handle it, it just will heat up over time. And for cooling the Peltier elements, I made this cooling system using water blocks. These are used for PCs, for cooling processors or graphics cards. I'll circulate water through a pot of water, which will cool our Peltier elements, because I don't have two identical radiators with fans. To ensure equal conditions, this setup will allow me to create them, and will measure the temperatures of the two Peltier elements under equal conditions. I won't apply thermal paste yet to avoid making a mess, as I'll apply it during the final installation. But for now, I'll just mount them on the water blocks, connect them, and measure the temperature. So here's what I've set up. I've connected the power supply. To it, I've connected a voltmeter ammeter so we can measure the consumed current and power of the Peltier elements. We'll connect each one in turn to see how much it consumes, because installing two separate voltmeters would result in an insane amount of wires. Here I've connected everything according to the diagram. I won't go into detail as I have a separate video on how to connect such voltmeters with an ammeter, how to connect them correctly. I'll leave a link in the description. And here, to this terminal block, we will connect the Peltier. I also took two temperature sensors. Oh, by the way, it's hard to see. This sensor is green, and this one is red. The red one is clearly visible, but the green one is practically not visible. Let me dim the light. So if you're choosing temperature sensors, keep in mind that the green one and red, but under lighting, the green one becomes very hard to see, practically invisible. So it's better to choose red or blue. The green one gets washed out and becomes hard to see. We'll fix one sensor from each onto the Peltier to measure how it cools. And I'll just take, I think, some electrical tape and wrap it like this and secure it. This will be faster and less time will be spent later on all this disassembly and cleanup. So we take and attach both the Peltier and the temperature sensor to the water block right away. There, one is done. And now the second one. I dimmed the light so it would be more visible. Now we're going to connect. First, let's connect. The negative can be connected permanently. We connect one connector and the second connector, connecting the negative permanently. As for the positive, we'll try them one by one now. First, let's see how much each consumes. Now we're connecting the new one, which is based on aluminum. Here we apply power. The current is 3.3 amperes. It changes periodically. Readings fluctuate. 30 watts at 12 volts. And by the way, I connected it incorrectly. The wrong way. It heated up. On the contrary, it started to get hot because I realized what the trick is. The side with the letters printed on it heats up. But here, it's the opposite. Where the letters are, on the white one, it cools, but here it heats up. I need to turn it the other way around. All right, take two. Power applied. 3.8 amperes current, 44.5 watts power at 12 volts. It started cooling. It's already 18 degrees, and the temperature is dropping. Okay, we measured it, 44 watts. The voltage is the same. Now let's connect the second Peltier. What do we get here? And here, at the same voltage, it consumes 30 watts. So this Peltier, the one with the aluminum base, consumes 15 watts more power than the white one. At 15.6 volts, the maximum current should be 6 amperes. So at 12 volts, it will be less. So this one is a 30-watt Peltier. It has already cooled down to 3 degrees Celsius. Here we have a 45-watt unit. Well, now I'll wait until the temperatures equalize. That is, it will heat up again. And we'll turn them on simultaneously and see which one performs better. Our temperatures have practically equalized, room temperature. So we're turning on both elements simultaneously. We have a current of 6.5 amps. The voltage has dropped slightly, and the power of both Peltiers is 73 watts. And now let's check the temperatures to see which one cools better and faster. Well, it's immediately clear that this one has pulled ahead slightly, cooling faster. This one is a bit slower, but let's see if it catches up over time. Let's see what the minimum temperature is. That's also important for a refrigerator. How much colder it will get. It's already below zero here. Soon condensation will start to accumulate and freeze here. This one is still reaching zero, and now a sub-zero temperature has started. Well, it's good that there are water blocks here, and the water that flows in is still cold, so it cools the Peltier well, allowing it to reach good temperatures. The conditions are the same for both. Water is supplied, distributed equally through a T-connector. The cooling is good, and the pump that circulates the water, I reviewed it in a previous video. So right now it is running at 5 volts, this little pump, so it doesn't make too much noise. So we could increase the circulation even more, but it's currently at its minimum setting. The return flow is still cold. It doesn't have time to heat up. It's barely warm. Well, if we compare, yes, the return flow from the aluminum Peltier is slightly warmer. So there's about a 3-degree difference. This one started 3 degrees ahead, and it turned out that it is 3 degrees colder. The temperature is no longer dropping below minus 10.5, minus 7.5. The water blocks are cold, meaning the heat dissipation is good. They don't heat up. Our water blocks are at room temperature. They don't heat up at all. The cooling is good. I can try to increase the circulation. I'll try to set a higher voltage for the pump and see if perhaps increasing the circulation will make the temperature drop. So I've set the pump to 12 volts. So I waited a bit. It worked, but there wasn't much difference. The Peltier on the aluminum substrate shows -11, and the regular ceramic Peltier shows -76. Well, that's almost a 3.5 degree, 3 to 4 degree difference. So this one is more efficient. I think for a refrigerator, this is significant because if one refrigerator has, say, +10 and this one has +7, then the refrigerator's performance will be better. Well, I'll put it in the refrigerator and we'll see how it works there. I think this is a good characteristic. Also, if you like the video, please like it and leave comments. In the next video, I can order a 2-stage Peltier element and look at its characteristics. Its hot and cold side temperature difference is around 45 degrees, so I think it can be cooled even further. Anyway, thanks everyone for watching. Bye everyone.